Hello all, welcome to my channel. So I would be today taking up next topic, electronic devices. So in this, first of all, you should know the difference between the solids or the solids characteristic. Now, the solids are classified into two parts. One is a crystalline and another is the amorphous. So whenever we have a crystalline structure, those are always arranged in a definite and a regular way. When we talk about amorphous, those are those which are arranged in an irregular manner and do not have any external geometrical shape, like glass, like rubber, and many more. So, according to class 12 syllabus, you need to know the energy bands in conductors, semiconductors, and insulators. So, first of all, if you want to start with these all, you should know how energy bands are formed. So for that, you should know what is single free atom and a crystal. So single free atoms, in a single free atom, we have only one type of atom. Now, in that, electrons have well-defined energy levels. That means they all have same energy levels. Now, when we talk about crystal, so in crystal, the atom do not have a well-defined energy level. Why? Because in crystal there are many atoms and each atom in the crystal is surrounded by neighboring atoms. Likewise, if we have a silicon, silicon is a crystal. So we have a silicon, silicon here, silicon here, silicon here. So therefore you can see that a single atom is surrounded by neighboring atoms of same element. So therefore, they have they don't have well-defined energy. So if they don't have well-defined energy, therefore they form two bands. One is valence band and another is conduction band. So from the name itself, from the name of valence band itself, you can see that you can say that they are made up of all the valence electrons of a single element. So this band is known as the energy band, formed by a series of energy levels containing valence electrons. Now when we talk about conduction band, so the conduction band is the lowest unfilled energy band formed just above the valence band. So now we would be talking about conductors, insulators, and semiconductors. So conduction band is the lowest unfilled energy level formed just above the valence band. So let's start with metals. So metals come under conductors itself. So, so first of all, in metals, the valence band may be completely filled and the conduction band partially filled with an extremely small energy gap between them. So the first case, let us make the conduction band and the valence band first of all. So this is my valence band suppose and this is my conduction band. Now the valence band is completely filled in the case of metals, and it is sometimes that the conduction band is partially filled. So that means the conduction band as well as valence band has some electrons in it. Now, if we apply a small current to this particular element or a crystal, then there could be basically we have a small energy which can be applied to this, and all the electrons will start flowing from valence band to the conduction band. Now, in the second case, we have two cases in metals, that is, suppose this will be the case of sodium. Now the second one, let it be, this is the case of zinc actually. In this, we have valence band and we have conduction band. In this, the conduction band is empty, but the valence band is filled. Valence band is completely filled in this, but the conduction band is unfilled. Now, in this case, as you can see, we don't have energy gap between the conduction band and valence band. So the electrons are readily allowed to be into the conduction band. It doesn't have to cross the forbidden band gap energy, which is defined as Eg. There is a forbidden gap energy between conduction band and valence band. So they don't have to travel much. So if you apply even a small electric field, the metal conducts electricity. So that's the reason behind it. Now, when we talk about insulators and semiconductors, they both are same, but there is a one difference in it. We have valence band, we have conduction band. Similarly, in the case of semiconductors, we again have valence band and conduction band. But when we talk, the valence band is filled. In the case of insulators, again in the semiconductors, the valence band is filled. But the difference is that the insulators have the forbidden band gap energy of 6.6 electrovolt, and in the case of semiconductors it is 1.1 electrovolt. Now, in the case of insulators, the forbidden gap is of 6.6 electrovolt, which means that a filled valence band to conduction band. When electric field is applied across such a solid, the electrons find it difficult to acquire such large amount of energy. They won't be able to acquire that much of energy to reach conduction band in the case of insulators. So therefore they are not able to conduct electricity. Now, when we talk about semiconductors, as you can see, they are both same, but the forbidden band gap energy in the case of semiconductors is 1.1 electrovolt. Now, due to this smaller width of forbidden energy gap, the electrons in the valence band find it comparatively easier to shift to the conduction band because it is of 1.1 electrovolt. So the conductivity of the silicon is in between the conductors and insulators. Therefore, they are known as semiconductors. The metals have a very less forbidden gap energy, that is of 0.5 electrovolt sometime, and sometime it is zero even, because as you can see in the case of zinc they are overlapping. That means Eg is zero in this case. So we named semiconductors because their conductivity lies between insulators and metals. So that's the end for this video. I will start with semiconductor types in the next video.